Hello, in this video we will be discussing about multinomial and exponential distribution. So, multinomial distribution is a generalization of binomial distribution. So, if you are familiar with binomial distribution, you will be able to understand multinomial distribution better. So, in my previous videos, I already explained what a binomial distribution is. So, any distribution or where the probability is 2. For example, when I toss a coin, so there are only two possible outcomes, either head will come or tail will come. So, the probability of each outcome is 1 by 2 or half. Okay, so in multinomial distribution, what happens is there can be multiple scenarios, multiple case scenarios. So the option is not limited to 2. Okay, we can get the options are more than 2. Okay, so it describes outcomes of multinomial scenarios, unlike binomials where the scenarios must be only 2. So to take an example of multinomial distribution, we can say blood type. Okay, so blood type of all the adults. So as you know that there are many blood types, A, B, O. Okay, so for example, blood type, or when we roll a dice. So when we roll a dice, there are 6 possible outcomes. Okay, so any number from 1 to 6 can come. So the probability of getting each outcome is 1 by 6. So this is what a multinomial distribution is. Okay, so multinomial distribution basically has 3 parameters. N is basically the number of possible outcomes. So when we roll a dice, the number of possible outcomes is 6. P-val or p-value is basically the list of probabilities of outcomes. So when we roll a dice, the probability of each outcome will be 1 by 6. Okay, then size is the shape of the returned array. So without wasting time, let's get to the coding part. So for using multinomial distribution, we require the random module, the Numpy library. So let's import that. So from Numpy import random, shift and enter. Okay. So my program has successfully imported random from the Numpy inside my program. Okay. So for now creating a multinomial distribution, I write x is equal to random dot multinomial and inside I will have to write the value of n. So this is the example in which I am considering rolling of a dice. So when we roll a dice, there are 6 possible outcomes. So the value of n will be 6. Then p-values. So I will have to give the probability of all the outcomes. So when I'm rolling the dice, the probability of getting a particular outcome is 1 by 6, because there are total 6 numbers in a dice. So inside my list, I will create a list kind of, and inside my list, I will write in all the probabilities 1 by 6, comma 1 by 6, comma 1 by 6, comma 1 by 6, comma 1 by 6, 1, 2, 3, 4, 5, one more time, 1 by 6. Okay, so I have listed all the probabilities of all the outcomes, and then I want to print. So I will write print, and inside the bracket I'll write x. Press shift and enter. So as you can see that we got 6 elements inside my list. Okay, so multinomial samples will not produce a single value. They will produce one value for each p-value. Okay, moving on. As generalization of binomial distribution, their visual representation and similarity of normal distribution is same as that of multi-binomial distribution. So what happens is that when we try to visualize it, it will look almost same as that of binomial distributions. Okay, all right. Now coming on to exponential distribution. So what is exponential distribution? Exponential, okay, first let me add a hashtag. How can I add a hashtag? Shift, okay. So exponential distribution is used for describing time till next event, for example failure or success. It has two parameters, scale and size, where scale is the inverse of rate, okay, default is 1, and then we have something called the size, where size is equal to the shape of the returned array. So suppose that I want to draw out a sample for exponential distribution with 2.0 scale, and the size is 2 rows and 3 columns. So the size will be 2 into 3, okay, and the scale or the inverse of rate, that will be is equal to 2. So what can we do? We have already successfully imported a random module, so we can straight away write x is equal to random dot exponential, and inside we can specify scale. So scale is equal to 2, comma, size, I said that we want 2 rows and 3 columns. So size we can write size equal to inside bracket 2 comma 3, okay. And in the next line I will write the printing statement to print x. Shift and enter. So this is what our exponential distribution. This is the exponential distribution which is created by the algorithm. Okay, moving on. Now we can visualize our exponential distribution. So for visualizing our exponential distribution, we will require a few libraries. For example, matplotlib, pyplot, seaborn. Okay. So for doing that, first let me add few cells. For adding few cells beneath it, I'll just click on this blank space where my mouse pointer is, and I'll type B. Okay, so I've successfully added few cells. Now I'll import the useful libraries which is required for visualization. So I'll import matplotlib dot pyplot as plt, and next I'll import seaborn as sns. Okay, so I've imported these two libraries. Okay, so now I will try to visualize the exponential distribution. So I'm combining the visualizing statement and creating statement together. So I will write sns dot dist plot, where dist plot means the distribution plot or the plotting of the distribution. sns dot dist plot, and inside I'll write random dot exponential size I will write as 1000. Okay, and I do not want a histogram, so I'll write histogram as false. I just want to see the curve. Okay, and then I'll write plt dot show, shift and enter. Okay, so there is the spelling error. So instead of writing size, I have written size. So size. Okay. So as you can see that this is what our graph looks like. This is what the curve of the exponential distribution. This is what it looks like. Okay. Now suppose that I want to add a histogram. Suppose that I want to add a histogram. So what will I do in that case? I will just make this thing true. Histogram is equal to, I'll just write true, T capital, shift and enter. So now we will be seeing histograms also. Okay, suppose that I forgot to mention about the histogram, so I completely omitted this histogram part. Okay, shift and enter. So by default histogram will appear. So if I completely forget to write histogram, then by default histogram will appear. Or we can, if we do not want, we can just write histogram is equal to false. Okay, suppose we want to see only the histogram and I do not want to see the curve, then in that case what should we do? We discussed about it in the earlier videos, so I would request you to go and go through the earlier videos, so you will be able to see it together. So all the videos are in the playlist, Numpy playlist. So I've started with the basics of Numpy and we discussed about many different distributions, and then we moved on to multinomial and exponential distribution. Next we'll be discussing about U functions. So everything you'll get in one particular playlist. So suppose that we do not want the curve, so I'll just write comma KDE, which is curve basically. KDE is equal to false. Shift and enter. So this time there is no curve. Okay, this time there is no curve. And if I write KDE is equal to true instead of writing KDE is equal to false, so we will be able to see a curve. So if I do not specify, specify the KDE, so by default it will show me the curve. But if I want to not see the curve, then I'll have to write KDE is equal to false. Okay, all right. So moving on, now we will discuss the relation between Poisson and exponential distribution. Okay, so the relation between the Poisson and exponential distribution. All right. Okay. So Poisson distribution deals with number of occurrences of an event in a time period, whereas exponential distribution deals with the time between these events. Okay. So I have already created a video on Poisson distribution. If you haven't seen the video, if you haven't checked out the video, you can check it out. So over there, I have said that Poisson distribution, it basically deals with the number of occurrences of an event. Okay, so in a particular time period, what is the number of occurrences of an event that is being dealt with by Poisson distribution? Whereas exponential distribution deals with the time between these events. Okay, if suppose two events are happening, so exponential distribution is basically dealing with the time between these two events. Okay, so I hope that you clearly understood what is an exponential distribution, what is a multinomial distribution. So we will meet again in the next video, and in the next video I'll be discussing about more distributions. I'll be discussing about chi-square and Rayleigh distribution. So see you again in the next video. Thank you.